Okay, now this is part number 3 of our first lecture in the in the introduction to communication module for year 3 computer. In this short part, actually, I'm going to join you with a journey with the MATLAB code that is somehow related to the Fourier series, Fourier transform, and their properties. We are going to show some MATLAB code, maybe one or two, and actually, we are going also to use such MATLAB code in order to investigate some important effects and parameters. It's a very short part with respect to the first and second, and maybe also the fourth part, but it may be helpful for you to understand some concepts and also to raise some important questions. So let me first start join you now in order to open the MATLAB folders I have. Okay, let's start with this one, for example. By the way, all these MATLAB codes are available over the e-learning. They are all from the MathWorks file exchange library. This nice interface we can make now run. Okay, and see. Okay, so no need for the camera, and then let's do it. Okay, so you can see now this full screen. Here you can adjust the frequency. So, for example, we have now we can change the time, you see. And of course, with changing the time, you got a different. Sorry. Okay, so by changing time, you can see that the sinusoidal signal start to change the position. The period is changing, and so the frequency is changing as well downstairs. So here is for you. Okay, but let's stop here for a screenshot for a while and ask a very important question. When we deal with such a sinusoidal wave in our lecture, I think I have the lecture here. So if you remember this slide, we say that the sinusoidal signal has a discrete single delta Dirac function in the frequency domain. If you remember this slide. But if you return here, let's now highlight a first question. I need your answer. What is this? It's not a pure delta Dirac function. There's something like harmonics everywhere on the right and the left. Still, it's a small harmonic, but it's not an ideal delta Dirac function. So maybe I'm just running this MATLAB code in order to observe this and turn it to your side. So please start to think. Maybe you can email me and answer. Why you recognize such small harmonics on the left and right of the delta Dirac function? Why it's not a pure delta Dirac function? So this is somehow important and also maybe useful for your understanding of the concepts. Okay, so this is the first MATLAB code. And let me go to show you another one. Another actually interesting one. So it's interesting for me, at least. So let's do it. Okay, this is very nice. Actually, this is the Fourier transform, one of the most famous sounds you know. Let me play the sound for you. Just need to check that I'm sharing my computer sound. So now I'm sharing my computer sound, and then let's play this music. I think all of you know this famous tune for the Windows. Now we input this famous tune here. Let me return back to the MATLAB. Okay, so this is our MATLAB code. Okay, perfect. This is the time domain signal. This is the sound in the time domain, as you can see. And this is the frequency domain signal. This is the allocation of the frequencies everywhere in the frequency domain. Just trying to make it both appear in one slide. Okay, so yeah, this is the time domain on the left-hand side, and this is the frequency domain on the right-hand side. You can see that the frequency is varying somehow in the sonic region. It reached something like 10K. That the top is 10K. I believe you see my mouse, and the down bottom is nearly below the 1K, or sorry, below the 10 hertz. So it's covering this visible, or sorry, not visible, this sonic or sound range, sound frequency portion. That's why we are hearing it. So this is a very nice example. Actually, the added value here that you have the capability to input voice and see the spectrum. So, for example, you can record your voice over the mic, and then you can run the same MATLAB code, but with your voice, not with the Windows Famous voice, and then you can check the spectrum or the frequency component of your voice. This is what I'm maybe motivating you to do. Maybe this is also a fourth bonus for this lecture up till now. So we have at least now four bonus. So this is another example. Let me go to a third one, and it should be a final one actually. This is also a very small demo related to the Fourier transform or to the rat sync function. So this is some famous formation for rat sync function here. You will see, I'm sorry, okay. I have to run the code, so I have to press any letter. So here, this code actually is working in a very good manner. I'm just not so good in showing different windows, but here what they have implemented is they first make a Fourier transform for the original signal of a rect function, and then after they got the sync, they return it back to the time domain, and here you can see that some high frequency component have disappeared. Maybe it's somehow interesting. We will deal more deeply with such an example, maybe when we go to the filter section number 2, I think. So you will know something more in details about why you are losing the high frequency component. But if you remember, during our first and second report, we have highlighted that high frequency components are always included in sharp edges. So when you find that these sharp edges are not ideal, you have to know that you lose some of high frequency component. It's important question why we are using high frequency component. Is it important to keep them or to lose them? This is actually maybe one of our interesting. As I mentioned, this is just a very small part to show some very quick MATLAB codes. All these codes are now available over the e-learning, so you can try by yourself. It's an open source, so you can even change a lot. As I mentioned, please go and do it by yourself. Please try to change. Maybe the easiest way is to change the audio file for the second code and check what will happen. So this also, for me, it's something interesting to make some sort of MATLAB exercises. I believe that such MATLAB exercises are always actually useful when we are talking about signals for each transformer for your field. So now this is a very short part number 3 for the first lecture. The next part will be now part number 4, dealing with what we can call Fourier properties and the linking between Fourier and the convolution theory. So see you in the next part number 4, my dear. Thank you very much.